Okay, so you know how we did parametric equations and polar equations back in 2 dimensions? So cylindrical and spherical coordinates are like an extension of polar coordinates in 3 dimensions. Okay, we're gonna start off soft with our cylindrical coordinates. Okay. Okay, so don't write this down, you already know this. What in 2 dimensions, polar coordinates, x equals r cosine theta, y equals r sine theta. Remember that? Did you say you don't remember this? No. You shouldn't need to. Okay, so r is the distance from the pole, theta is our angle. Okay. R is the square root of x squared plus y squared. Inverse tangent of y over x gives us theta. Okay, you remember all that? Let's just talk about this. This distance right here in purple is x. This distance right here in blue is y. X squared plus y squared equals r squared, right? The tangent of theta is y over x. The cosine of theta is x over r. The sine of theta is y over r. That's where all of these came from, just simple trigonometry. Okay, what we're gonna do in the 3rd dimension is we're gonna have polar coordinates. We're gonna have a coordinate r, comma theta, comma z. So basically, we're gonna move in the xy plane polarly and then up and down with z. So that's why we call these cylindrical coordinates, because we move circularly in the xy plane and then up or down with the z. Yeah. Cylindrical, right now, that's my plan. But if we need to keep pushing forward, we can keep pushing forward. So this is what you need to know. Basically, we have polar coordinates with z. Z equals z. R, comma theta, comma z. Now wait for Rachel. And then she's not here today, so I'll get him tomorrow. Right? Yeah. We see right through you, Rachel. Do we have this written down? Oh, the cylinder. What? Ready? Okay, so let's start with this one. This is a rectangular coordinate and we want to convert it to cylindrical. Hey, a third of the work's already done for us. Evie, I'm supposed to ask you about vector.
Oh, yeah. I'll show you later.
We watched vector yesterday.
Yeah.
Okay.
Everyone was telling me about that. Oh, that's good.
I just can't wait to see around it. Isn't it cool that Z's already given to us, right? So now we have X and Y that we need to convert to R and theta. Well, if we have X and Y, we can take X squared plus Y squared equals R squared. R is 4. Okay. We also know that the tangent of theta is y over x. Well, we got to be careful. So the tangent of theta equals -1. That happens in 2 different places. It happens at 3 pi over 4 and 5 pi over 4. If this is x comma y, which one is it? Excuse me, it happens at 3 pi over 4 or 7 pi over 4? 7 pi over 4. So this coordinate is r comma theta comma z. If you gave me the angle of negative pi over 4, I would accept that also. Okay. All right, how about you try this one for me?
Yeah.
Nope. Think about which quadrant xy plane -1 is represented. Okay, so you third quadrant. Dane, what's R? Andre, what's theta? So our coordinate is r, comma, theta, comma. This one's like straighter, that one's a little crooked. Didn't know my handwriting was getting judged so intently. All right, let's go the other way. Now I have a cylindrical coordinate that I want to be rectangular. I had to think about what the word was. Okay, so A, Z is Z. We know X is R cosine theta and Y is R sine theta. What's our X coordinate? Y coordinate? So this converts to be 0, 4, -2. Okay, let's talk about the difference in how we approach plotting these two coordinates, okay? A rectangular coordinate, we're gonna basically move along a rectangular prism, right? We're gonna go out 0 on the x-axis, then we're gonna jog 4 in the positive direction along the y-axis, and then from that coordinate, move down 2 along the z, okay? Versus if we have a cylindrical coordinate, we're going to rotate to pi over 2 and move out along that angle 4, and then take that coordinate and move it up 2, down 2 on the z, okay? Does that make sense? So basically, we move along like a rectangle, right? X, Y, and then we move it up or down. Or over here, we rotate to an angle, move out, and then we can move it with the Z. You're giving me a funny look. Are you okay with that explanation? Okay. All right, you try this one. Like here, B for oh, yeah, you just with the wind and everything. Yeah. Also the game he broke. Christian Fiddle Thursday. Against Wait. Thank you. All right. Grace, what's our coordinate? Grace. Always Grace. You have a nice picture on Facebook and Twitter and Instagram. All right, so now let's talk about equations. I have the cylindrical equation theta equals pi over 4, and we want to convert it to a rectangular coordinate equation. So write theta equals pi over 4. Okay, here are our different conversions in z equals z. I need to get this from cylindrical to rectangular. So to rectangular means I want x's and y's and z's. I don't want to think. What can we use? Okay, the tangent of theta is y over x. So if we say that the tangent of theta equals the tangent of pi over 4, right? If we do something to one side, we can do it to the other side. The tangent of theta we can replace with y over x. What is the tangent of pi over 4? Okay, so we have the equation y equals x. Now, in 2 dimensions, y equals x is a line. In 3 dimensions, y equals x would be a next example. It was an equation. So we're going to keep it as an equation. All right. From cylindrical to rectangular, again, we have r squared plus z squared equals 9. Suggestions? R squared is x squared plus y squared. And now we're in x's and y's and z's. What do we got? What is this? Sphere with radius 3. Center at 0, 0, 0. All right, let's go the other way. Let's go from rectangular to cylindrical. When we're going from rectangular to cylindrical, majority of the time, these are going to help you the most. I'm not saying all the time, I'm just saying the majority of the time. Okay. So we can replace x with r cosine theta. We can replace y with r. When we had our polar coordinates, if we could, we tried to solve for r. I think that that's something that we can do in this case. Okay, we can divide both sides by r, excuse me, and then we can divide over that cosine. So we have sine theta secant theta. Oh, no. Yep. Or if you wanted to be crazy and call it tangent times secant, you could do that too. Secant squared is 1 over cosine squared. Okay. Sine over cosine is tangent. Okay. Okay, so some of the common uses would be to give the equation of a surface of revolution. Okay. So like a paraboloid is a surface that we rotate a parabola in the XY plane about the Z axis, and then we have like a bowl that's like a parabola. Okay. Right, you're giving me a really weird look. Okay. So it wouldn't be like a let's rotate it and find the volume kind of thing. Like that is the equation. When we have cylindrical coordinates, we can just write it like this. What? So we actually like skipped a couple sections in chapter 11. So there's an entire section where we can talk about ellipsoids and paraboloids and hyperbolic parabolas and like all of these like basically conics but in 3 dimensions. Okay, so here we have a sphere. Okay, a right circular cone would be like Z equals some slope times R. A helix, R equals some letter. Okay, Z equals a number times theta. Yeah. Okay, so let's talk about these. R equals 5 in cylindrical coordinates. What is R equals 5? So in 2 dimensions, it'd be a circle. Then in cylindrical coordinates, it would be a cylinder. Okay. Cylinder with radius 5. Okay. What about r squared plus z squared equals 100? What is that? You're about to say square root of 100, weren't you? Luckily, Evan saved you. This is the crazy one. Z equals R. A right circular cone. So this is basically the radius equals the height. Okay, we have a cone. A cone where the radius equals the height. But I'm not gonna make you find any like conical piles of sand.
You could find volume.
We could. Okay, so here's the deal. We have 10 minutes left of class. This is where I was planning to stop. We cannot get all the way through the next lesson. So here are your options. We spend 10 minutes starting the 11-7 homework, or I give you the equations for spherical coordinates and we continue with how to use them on Thursday. Start your homework. Everyone has to actually do it though. Yes.